Let's begin learning how to solve one-step equations. And that's right, it is only one step. And all of these equations look like this, where x is going to stand for our variable. I'll write VAR. These here, both of these, even though they look like variables, they actually represent values. These are number values. And you'll see what these look like here once we do a few of these practice ones. So we have a variable, we're going to add some number to it, and it's going to equal another number, essentially. Now then you will be asked many times over again to solve an equation. And then you will be confused and be like, what does that mean? But then you won't be confused anymore because you'll remember that it means to solve the value, it's to find the value of the variable. So you look at the variable and you're like, I'm going to try to figure out what you are worth. Because variables are mystery numbers. And when you find the value of them, it is no longer a mystery, which means you have solved the mystery. You have solved the equation. So solve an equation means find the value of the variable. And there's three methods to do that. The first one is called inspection, which is guessing and checking. And you'll see we'll do some examples of those. The second method is to model the equation on a scale and balance the values. I'll show you what that looks like as well. And the most practical method of solving a variable involves isolating the variable. I've highlighted isolate because you need to know what that means. And isolation means, well, we'll get to it once we get to the examples, but isolate the variable by performing the opposite, circle this word, opposite operation on both sides of the equation. Here's method one, inspection. Guess and check. This is not hard. J plus 6 equals 16, or in other words, a mystery number plus 6 is 16. Some of you are raising your hand in the air because you know that J must be 10. Because 10 plus 6 equals 16. And look at this. 16, this makes 16, equals 16, and left side equals right side. That is important. So J must be worth 10. How about that second? Now that looks like a lot of work just to prove that J is 10, but it's essential. You got to be able to go through these steps here and prove that the left side is equal to the right side. Look at the second example. 23 minus some number equals 11. How about 23 take away 10? Nope, that's 13. 23 take away 12. How about that? That works. So we're going to write this here is going to be 12. So 23 take away 12 equals 11. Let's prove it. 23 take away 12. What does that make? It makes 11. And the other side says 11, and left side equals right side. That is the ultimate proof that it works. Let's look at this one. 17 equals some mystery number minus 9. In other words, if you take a mystery number and you minus 9 from it, you get 17. What's that mystery number? Well, very quickly, you will realize that it's 26. Because if you take 26 and you minus 9, you will get exactly 17. And the other side is 17. Left side equals what? Equals right side. And we have proved it. This is a check mark. This is a check mark. This is a check mark. This is just using some logic. That's what this method involves. Let's skip to method 2. Model on a scale and balance. We have J plus 6 equals 16. A mystery number, we can use a cup for that. We can put the mystery number inside the cup. Put it all in here. We got mystery amount. We don't know what it is. We can call it J instead of check question mark. We'll put a J. And we have 6 more, and on the other side we have 16. And we know that the scale is balanced. So what does that mean? It means that altogether on the side we must also have 16. This is not a hard question to do and figure out that, oh, it must be 10 because 10 plus 6 is 16. But let me show you something here, what I want you to do on a test if you ever get a scale or if I ask you to draw a scale. I want you to knock off one counter from the left side. And then here's the problem with doing that though. If you knock a counter off from the left side, what side is heavier? That side. You know what the scale's going to do? It's going to tip over like that. That's no good. We want the scale balanced. So we'll knock off one from this side. Okay, now it's balanced again. Then I knock one off here. And that means I have to knock one off here to keep the scale balanced. I'm going to knock one off here and keep repeating it, Xing them off one at a time as I go. And that keeps the scale in balance until, look what happens. Remember what's missing here in the middle? I forgot to put this, but it's an equal sign. Because the scale is balanced, I need that equal sign. And look what it says now. After I removed all these extra ones here, I just get J, the mystery amount, is equal to 2, 4, 6, 8, 10. That mystery amount, J, is equal to 10. Didn't we say that over here, J is 10? And now we proved it using a model of a scale. If you don't like using cups, you can use any of these. You can replace the cup and put one of these instead. Or put one of these. You can change the letter if you want. If you don't want to use J, you can use N or anything else that you want. Let's throw a word problem into method 2. We've got John scored 15 goals in a soccer season. This was 6 more goals than his friend Matt. How many goals did Matt score? I want to bring your attention to this word, this. When it says this was 6 more goals than his friend Matt, what does that mean, this? It means the last thing that we talked about. John scored 15 goals. It's the 15 goals was 6 more. So we're going to write 15 over top of this. So we got 15. Now, the word was, that's the same as the word is. And it all means equals. If you see was or is, that all means equals. So we're going to say 15 equals 6 more goals than his friend Matt. Do we know how much Matt scored? No. We know how much John scored. So we don't need to write we don't write a J because we know how much he scored. But Matt, we don't know. So we can write M. And we're going to write 15 equals 6 more than Matt. So was, is, all means the same, means equals 6 more goals than Matt. So we're going to write Matt plus 6. Then it says write the equation. Well, guess what? We just did. We just wrote the equation. It's right here. And the question asks us, how many goals did Matt score? We got to figure that out. We can use this old strategy of inspection, but we're not supposed to. We have to use the balancing method. So you know what I'm going to do is I'm going to write it like this. And really the order doesn't matter. I can write M plus 6 equals 15. Or I can write 15 equals M plus 6. Does 1 plus 1 equals 2 make any difference as if I put the 2 on the other side and said this? Of course not. So I can flip it around. It doesn't really matter. But I chose, for my diagram, I chose this method here. And I put the 15 on this side. And on the other side, I wrote M plus 6. So I have my M, my mystery number of goals that Matt scored. It's all in the cup. I don't know how much it is yet, but I'm going to increase it by 6, and that should be equal. My teeter-totter should be balanced. So let's take a look at this here and say, let's knock all these 6 off. This is only what you do with the teeter-totter method. But if I knock 6 off here, this side is going to get so heavy and it's going to tip over. I don't want that because that says equals, and equals means balance and harmony and love and peace and all the good stuff in the world. So let's take away 6 over here just to make it kind. 1, 2, 3, 4, 5, 6. Now the teeter-totter is balanced. I took 6 off the right. I took 6 off the left. The teeter-totter is flat. And look what it says. It says 1, 2, 3, 4, 5, 6, 7, 8, 9. It says 9 equals M. What does M represent again? Right, it's Matt's score. Matt scored 9 goals. Now we have to check it just to make sure. How many goals did Matt score? He scored 9 goals. But let's check it. Let's write 15 equals m plus 6. Let's replace Matt with 9 goals. We're going to substitute 9 plus 6. We'll write the 15 here. Now, bear with me here. 15 equals, well, what's 9 plus 6? 15. Left side equals right side. I did the question correctly. What are these things here? All they mean is I don't even need to use cups. I could have used any of these instead, and it would have been perfectly fine. Get used to using a variety of them. Method 3, isolate the variable by performing the opposite operation. This one's going to be really quick, ladies and gentlemen. Isolate means exactly what we did in the balance method. Remember when we had all of these bollies sitting beside the M? And I had all of these here, and they were, of course, sitting there. But isolate means put the variable all alone. Lock him up by himself. All these constants beside him, get rid of them. So you're going to minus all these 6, isolate it, and then you're going to minus 6 from the other side, which is what we did. I won't do it again. So showing this over here, we've got plus 32. Let's do the opposite. Write it exactly how I show you. Minus 32 underneath. That's the opposite. On the other side of the balance of the teeter-totter, you're going to write minus 32 as well. 55 minus 32. Let's see, 5 minus 2 is 3. This makes 23 equals, what's 32 minus 32? They're gone. The C has been isolated. It's all alone, and C is equal to 23. Of course, we need to check using substitution. So we're going to put the 23 right there, switch it to 23, add 32, write the equals, and then the 55. Go ahead and write it down exactly like this. Now, find the answer to this. It's going to be 55, and look what's on the other side. It's also 55. Left side equals right side. Now we're going to do this more advanced way, just like the soccer one, but we're going to do it with method 3. Mike scored 22 goals. Is that a mystery? No. Do I need a variable for Mike? No, I don't need that. I know how much he scored. This was 15 goals less than his teammate Jeff. What's this? What is it talking about? It's talking about the 22 goals. Was means equals. Underline was. It means equals. 15 goals less than his teammate Jeff. Do I know how much Jeff scored? No, that's what the question's asking. So I'm going to write Jeff minus 15. That's 15 less than Jeff. Take Jeff's goals and minus 15 and you will get 22. That's my equation. So let's write it down. We're going to get 22 equals J minus 15. This method involves doing the opposite, so I'm going to go plus 15 and plus 15. That's it. Make your line and solve it. This makes nothing. This makes J. Mr. Melham, why nothing? Because negative 15 plus 15 just cancels out. And then we get J, and this other side it says 37. So that means Jeff scored 37. Remember, J means Jeff. Now check using substitution. We're going to stick it right in there. We're going to get 22 equals, I won't write J, I'll write 37. Because that's how much he scored according to this. Minus 15. Let's figure this out. This means 22. This is 22. Oh, look at that. Left side equals right side. And we checked this, we solved it, and we wrote the equation all in one. So what did we learn today? We learned that to solve an equation means you need to find the value of the variable. You can solve using 3 methods. Do you remember the 3 methods? There was inspection. There was scale balance. And there was isolate using the opposite operation. The opposite operation. And we learned how to check our answers using substitution, and then verifying using the left side equals right side. If we got that right, means you did it right. Talk to you later.